Good day, everyone. So today we will have our last lesson in our block 5. So before we proceed with our proper lesson, we'll start with the word problem. Chris ate 2/7 of the cake. Patricia ate 3/7 of the cake. Who ate more cake and how much? How much cake did they have together? How much cake is left? So as you can see, we have 3 questions that we need to solve or to answer using our important details given in our word problem. So let's start answering it.
Okay, so after reading the word problem about Chris and Patricia, we can now identify what would be who ate more cake between them. So the first thing we need to do is to find out what is the fraction of Chris and Patricia. So the given number would be Chris, that is 2/7, and Patricia has 37. If we will illustrate this one into a pie, we can identify which has more or less slice of cake. So we'll encircle here and cut it into 7 parts. Okay, so we need to cut it into 7 parts. So as you can see now, we have divided equal part for 7 parts of cake. So we need to shade 2. 1, 2. How about in Patricia? Okay, we need to cut it again into 7 parts and shade 3 of it. 1, 2, 3. So which has more shaded part? Okay, very good. That is Patricia. So we can say that Patricia ate more cakes. Now, we need to find out by how much did Patricia ate more cakes. So, in able for us to find that one, we need to subtract the number of Patricia to Chris 8 slices of cake. So we have 37 minus 27. So as you can see, your denominator are the same. So just copy them. And 3 minus 2, that's 1. So we can see that she ate 1/7 more. Now, the second question would be, how much cake did they have together? Have together. When you say together, that is a keyword for addition. So we'll need to add our 2/7 and 3/7. So we need to have here 2/7 plus 3/7. Again, you have the same denominator. So we'll just copy 7. 2 plus 3, that is 5. So we can see that together they had five, 7 of the cake. So all in all, they ate together 5, 7. And the last question na, how much cake is left? Okay? Again, how much cake was left? So if we will find out what would be the remaining slice of cake. So we have here, okay, so we need to slice it into 7 parts. Okay, the first thing is we shade the part of Chris. He ate 2 parts, right? While Patricia ate 3 parts. So 1, 2, 3. So how many is unshaded part? We'll count 1, 2. So as you can see here, after shading 2 parts for Chris and 3 parts for Patricia, we have 2 left. So 1 and 2. So we can see that there are 2 over how many slices in all? Okay, very good. That is 7. Or 2/7. There are 2/7 cake left.
So today we will learn about solving word problems. Again, today we will learn about solving word problems. So this would be our aim for today. We will solve some word problems on adding and subtracting unlike fractions. Again, we will solve word problems on adding and subtracting unlike fractions. Again, when you say unlike fractions, our denominators are different. So we will solve fractions that has or have different denominators. So let's have letter A. We have Jacob bought 2/5 meter of rope and Maria bought 4/9 meter of rope. What is the total length of the rope they bought? Again, in letter A, we have Jacob bought 2/5 meter of rope and Maria bought 2/9 meter of rope. What is the total length of the rope they bought?
So letter A, after reading the word problem about Jacob and Maria, we need to find out what are the given numbers. So we have Jacob, which is equal to 2/5 meter of rope, while Maria has 4/9 meter rope. So what is the keyword there? Okay, very good. The keyword there is total length. When we say total, it represents addition. So we need to add the fraction or the length of the rope of Jacob and Maria. So we have 2/5 plus 4/9. So as you can see, we have unlike fractions, right? So we need to find out first our LCM, or least common multiples. So we have 5 and 9. So let's start with 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So, and so on. How about 9? We have 9, 18, 27, 36, 45, and so on. So as you can see, we have the least common multiple between them is 45. So we need to get the equivalent fraction, and it will for us to find out what would be the total length of the rope of Jacob and Maria. So let's copy the 2/5. How much do I need to multiply to 5 to get 45? So we'll count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to multiply it by 9. And do not forget your operation, which is plus. Copy again your 4/9. Okay, how many do I need to multiply to 9 to get 45? So let's count. 1, 2, 3, 4, 5. So we need to multiply it by 5. And also with your denominator, multiply it again with 5. So after getting the equivalent fraction, we need to solve the following. 2 times 9, that is 18. 5 times 9, that is 45. Okay? Plus 4 times 5, it's 20. 9 times 5, 45. So now that we have like fractions, we can now simply add our numerator and copy our denominator. Okay, 18 plus 20, that is 38 over, copy your 45, we got 38 over 45. Do we have a common between them? No more. So we can see that 38 over 45 is the total length of Jacob and Maria. So we can say that in a sentence that the total length of rope. The total length of rope is 38 over 45 meters.
So let's have letter B. Katerina bought 1 and 7/8 meter of ribbon. She used 1 and 3/5 meter of ribbon. How much ribbon is left? Katrina bought 1 and 7/8 meter of ribbon. She used 1 and 3/5 meter of ribbon. How much ribbon is left?
Okay, let's have a Larby wherein we are pertaining with Katerina bought a ribbon. Okay, so we have the given numbers of this is the bought ribbon wherein she has 1 and 7/8 meters, while she used 1 and 3/5 meters. So what is the keyword there? Okay, so even though we are not asking for the keyword in our question, we have the word used. So when you say used, you will take away wherein the operation there, or in the question we have the word left, that would be subtraction. So we need to subtract 1 and 7/8 minus 1 and 3/5. Now I want you to pause the video to answer the following and find out what would be the ribbon left in Katrina's problem. Again, I want you to pause the video and able for you to find out what would be the left ribbon of Katrina. So let's check your answers. What is the first thing we need to do? Okay, very good. So as we observe here, we have mixed numbers. So we need to, the first thing we need to do is convert mixed number into improper fraction. Okay, so how do we convert mixed number into improper fraction? Very good. We need to multiply our denominator to the whole number and added it in our numerator, the same as in our second fraction. We need to multiply denominator to the whole number and added the result to our numerator. So let's find out. 8 times 1, that is 8 plus 7, 15 over 8 minus 5 times 1, that is 5 plus 3, it's 8, 5. So now we have the new fractions of 15 over 8 minus 8 over 5. So what is the first thing we need to do? Because it is unlike fraction, we need to find least common multiple. Okay, so we need to have let's do the listing method. 8, 16, 24, 32, 40, and so on. Okay, let's have 5. 10, 15, 20, 25, 30, 35, 40. So as we can see, we have a common multiples of 40. So we need to do the equivalent fraction, wherein we need to multiply to get the same denominators. So we have 15 over 18 times. How do I need to multiply, or how many do I need to multiply to 8 to get 40? So let's count 1, 2, 3, 4, 5. So we need to multiply it by 5 minus. Okay, copy your 8 over 5. Okay, how many do I need to multiply to 5 to get 40? Again, let's count 1, 2, 3, 4, 5, 6, 7, 8. So we need to multiply it by 8. So we need to solve now. 15 times 5. Okay, we have 15, 30, 45, 60, 75. 75 over 8 times 5, that would be 40. Minus 8 times 8, how many? Okay, very good. That is 64 over 5 times 8, that is 40. So now that we are done with our equivalent fraction, we need to solve the following by subtracting our numerator and copy our denominator. 75 minus 64. Again, 75 minus 64. How many? It's okay, very good. That is 11. So we can see that the total length or the length of ribbon left is 11 over 40 meters long.
So let's have our last activity, letter C. Nick takes 2 and 2/7 minutes to complete one round of the park. Anna takes 9/4 minutes to complete one round of the same park. Who takes less time and by what fraction? Again, Nick takes 2 and 2/7 minutes to complete one round of the park. Anna takes 9/4 minutes to complete one round of the same park. Who takes less and by what fraction?
Okay, so now we'll have your last activity for this offline class, wherein it's pertaining with the time of Nick and Anna. So, first thing we need to do after reading the word problem is to find out what are the given or important numbers that we need to find out as the hint for solving the problem. So, the first given number there is Nick. Okay, Nick has 2 and 2/7 minute of running around in a park, while Anna has 9/4 minute running around the same park. So it's asking for who takes less time. So do we need to solve? Not yet, because we are still looking for who takes less time. So can we identify who takes less time here? Not yet, because we have a mixed number and improper fraction. So we need first to convert our mixed number into improper fraction. So 7 times 2, that is 14. Plus 2, it's 16. So we have 16/7 and 9/4. Can we identify which has a small minute of running around a same park? Not yet, because our denominators are different, right? So we need to find out what would be the LCM to get the least time of running around in the park. So find the least common multiple of 7 and 4. So let's start with 7. 7, 14. Okay, should be 1. 7, 14, 21, 28, 30, 5, and so on. While 4, 8, 12, 16, 20, 24, 28, 30, 2, and so on. So as we observe, the least or the common multiple between them is 28. So we need to find out. So let's have first Nick, which is 16/7. We need to multiply it by how many? Let's count until we reach 28. 1, 2, 3, 4. So we need to multiply both numerator and denominator by 4. So we need to identify here. 16 times 4, how many? Oh, you need to do the manual. 4 times 6, that is 24. Carry 2. Okay. 4 times 1, it's 4, plus 2, it's 6. So we got 64. While 7 times 4, that is 28. So we can see that 64/28 minutes. While Anna, let's have Anna, which is 9/4. We need to multiply it. How many do we need to multiply to 4 to get 28? Let's count again. 1, 2, 3, 4, 5, 6, 7. So we need to multiply 7 both in our numerator and denominator. 9 times 7, how many? That is 63. 4 times 7, it's 28. So as you observe, we have now the same denominators, right? So look at your numerator, which has a small numerator. Is it 64 or 63? Okay, very good. That is 63. So we can see that Anna has or takes less time than Nick. But then there is a question, by what fraction? When you say by what fraction, we need to subtract. So we have here 64/28 minus 63 over 28. So we need to subtract it directly because your denominator are the same. So 64 minus 63, that is 1. So we can say that Anna takes 1 over 8 or 1/8 or 1/28 minutes less than Nick. So this is how we find out the finding of the less time takes.
So as we do the process of solving word problems in our activities, how do we solve word problems on adding and subtracting unlike fractions? What did you do? What are the process did you do? Okay, very good. The first, read the problem carefully. Second is convert the mixed fractions into improper fractions if necessary. And the third one is look for keywords that represent addition and subtraction. Fourth one would be find the least common multiple of the denominators to help us add the fractions easily or to subtract easily. And the fifth one is you need to simplify your answer if necessary. When is that necessary? We can simplify our answer when our answer comes into improper fraction. So improper fraction, we need to convert it into a mixed number to get our final answer. So now that you know how to solve the word problem based on adding and subtracting, I want you to get your workbook. So that would be your offline class activity today in page 28. Again, I want you to get your workbook and do your offline classwork in page 28. So that would be all for today. God bless.